Good afternoon, everyone. Today I'll be talking about machine learning for information retrieval, or ML for IR. Information retrieval is the process of fetching relevant data from massive collections, like search engines pulling up results based on our queries. But traditional IR methods have limitations, and that's where machine learning comes in. ML has transformed IR by enabling systems to understand context, improve ranking, and continuously learn from user interactions. Throughout this presentation, I'll discuss the key techniques, benefits, challenges, and future directions of ML in IR. Introduction to ML in IR. Traditional IR systems rely heavily on keyword matching, which means they look for exact word matches in documents. But we as humans search in different ways, sometimes using synonyms, incomplete sentences, or even vague queries. Machine learning helps IR systems understand patterns in data learned from past interactions and improve search relevance over time. This is why ML plays a crucial role in modern search engines, recommendation systems, and even chatbots. ML enhances IR by learning patterns from data. Traditional IR versus machine learning based IR. Let's compare traditional IR with machine learning based IR. Traditional IR methods work by keyword matching. If a query matches words in a document, it gets retrieved. This approach misses out on context and fails to capture user intent. On the other hand, advantages of ML in IR. ML based IR goes beyond just keywords. It learns from patterns, user interactions, and context to provide more relevant result. A great example is Google search, which no longer just looks for exact words but tries to understand the intent behind your query. By learning from user behavior and feedback, ML based IR systems become better over time, offering more accurate and relevant results. Some of the key ML techniques for IR are: machine learning offers several techniques for improving IR. The key methods include supervised learning, where models are trained on labeled data to classify documents or predict ranking. Some of the examples are classification and regression models. Unsupervised learning. It discovers the hidden patterns in data, like clustering similar documents. The examples for unsupervised learning are clustering and topic modeling. Reinforcement learning. It fine tunes the results based on user interactions and feedback. Deep learning approaches, where neural networks power advanced search engines and chatbots. These techniques help make IR systems more dynamic and intelligent. These are some of the key techniques for IR. Supervised learning in IR. Supervised learning is one of the most widely used ML techniques in IR. It works by training models on labeled data, where the system learns to associate queries with relevant documents. For example, document classification helps categorize news articles, while query intent prediction it determines whether a user wants to buy something, read information, or find a location. Common algorithms used here include decision trees, support vector machines, and neural networks. Unsupervised learning in IR. It finds hidden patterns without labeled data. It is useful when we don't have labeled data. Instead, the system finds patterns on its own. A great example is clustering, where similar documents are grouped together, like how Netflix organizes movies into categories based on similarities. Another topic is topic modeling, which automatically identifies themes in large text collections, helping researchers and businesses analyze trends in documents. Some of the common algorithms are k-means, hierarchical clustering, and LDA. Deep learning in IR. Neural networks, it improves text understanding. Some of the examples are BERT transformer models for document ranking, and it is also used in search engines and chatbots. Deep learning takes ML a step further by using neural networks to process language and improve search results. The most well-known models include BERT and transformers, which power modern search engines by understanding the meaning of queries rather than just matching keywords. These models are also used in chatbots like ChatGPT or customer support bots to improve interaction quality. Natural language processing techniques in IR. NLP is crucial for understanding human language in IR. NLP techniques like sentiment analysis, name entity recognition, and text summarization help models understand the content and intent of documents. Some of the applications in IR are NLP is used to analyze queries, summarize documents, and recognize important entities, all of which improve relevance and retrieval accuracy in IR. NLP is essential for making IR systems understand human language. NLP techniques like sentiment analysis, named entity recognition, and text summarization help search engines grasp the intent. For example, when you search for best restaurants near me, NLP helps the system understand that you're looking for recommendations, not just a random list of restaurants. Some of the applications of NLP are email filtering, language translation, smart assistant, document analysis, online searches, predictive text, automatic summarization, social media monitoring, chatbots, and sentiment analysis. Ranking models in ML for IR. Ranking is one of the most critical aspects of IR. No one wants to see irrelevant results at the top of their search. Machine learning improves ranking through learning to rank models, which optimize the order in which search results are displayed. There are three main approaches: pointwise, where individual documents are scored; pairwise, which compares two results and ranks them; listwise, which optimizes an entire list of results. A real-world example is Google's PageRank, which originally ranked pages based on the links but now incorporates ML for smarter ranking. Feature engineering for IR. Feature engineering is all about extracting useful information from text to improve IR. Some of the most important features include TF-IDF and BM25, which help determine the importance of words in a document; word embeddings, which capture the meaning of words beyond simple keyword matching; click-through data for ranking improvement. User behavior data like click-through rates helps refine ranking based on what users find useful. One of the example is analyzing user behavior to refine search results. Challenges in applying ML to IR. While ML has greatly improved IR, there are still challenges. Data requirements. Machine learning models need a huge amount of training data, which can be difficult to collect and label. Gathering and labeling this data can be resource intensive, especially for specialized IR tasks. Computational demands. Training ML models is computationally expensive, requiring powerful hardware and memory, This can be a challenge for deploying ML in large scale IR systems. Training ML models is expensive and requires powerful hardware. Adaptability. Another challenge is adapting to changing user behavior and new information as models need to be continually updated to stay relevant. User behavior changes over time, so models need frequent updates to stay relevant. These challenges are why research in ML for IR is constantly evolving. Future of ML in IR. The future of IR is exciting. We are seeing advancements in neural search models, which improve context understanding, integration with conversational AI, meaning smarter chatbots and virtual assistants, personalized and context aware search engines, where results are tailored specifically to each user's preferences. As AI continues to advance, we'll see even more accurate and intelligent IR systems. Summary and key takeaways. Recap. Machine learning has brought significant advancements to IR by enabling systems to learn from data and improve relevance. ML techniques like supervised learning, query expansion, and learning to rank have all contributed to better search experiences. Conclusion. ML in IR continues to evolve, setting new standards for how we retrieve information and how well we search systems meet user needs. To wrap up, machine learning has transformed information retrieval by making search systems smarter and more adaptive. We discussed supervised learning, unsupervised learning, deep learning, NLP, and ranking models, all of which contribute to better search experiences. The key takeaway is that ML powered IR is not just about finding information, it's about understanding what users actually need. Closing remarks. Looking forward, as machine learning techniques improve, we'll see even more personalized and adaptable IR systems. The goal is to make IR systems that are smarter, fairer, and more useful for a wide range of applications. Open discussion. Thank you for your attention. I'd be happy to answer any questions about how machine learning is used in information retrieval and where the field is headed. Looking ahead, ML for IR will continue to evolve, making search engines even more personalized and efficient. As researchers and developers, our goal is to build IR systems that are smarter, fairer, and more useful for everyone. Coming to the conclusion, machine learning significantly enhances information retrieval. It also improves ranking relevance and personalization. It also allows future advancements which will further refine search accuracy. In summary, machine learning significantly enhances information retrieval by improving ranking, relevance, and personalization. As we move forward, advances in AI will continue to refine search accuracy and user experiences. ML driven IR is shaping the future of how we interact with information. Thank you for your time, and I'd be happy to answer any questions.